And this is 2 tests. So we have chapter 4, which will be a standalone test. It's like what we did for calculus. It's going to be rules of integration, and then we'll have a test, and then we'll do the applications of integration, and then we'll have another test. And they're both very short units, a bit like the previous 2 units the previous unit we've done.
It seems like there's not that much content in these tests.
No, it's much shorter than the calculus ones that we did. Yep.
And the conjecture one in integration.
There will be some conjecture problems in both integration and apps of integration. Yep.
Lovely.
So we won't necessarily put a conjecture question in both tests, but conjectures can be assessed in these tests. Okay? Yeah. But we've got. I don't know. I'm not making any confirmations just yet. We haven't written those tests. I just printed this booklet. I haven't decided. So so chapter 4, nice short unit. Rules of integration. Chapter 5, nice short unit. So we'll finish both of these before the end of the term. Hopefully we'll get about a week to work on our folio task, and that'll take us into the end of term. Will's got another question.
Why does it go 4A, D, E, F?
Good. So let's flip the page over and let's read the first thing that I've written there. It says, the textbook does a very poor job of ordering this unit. Okay, so this is the order that we are going to do the unit in. Okay, so I've taught it for like 10 years now, and this is the best way for us to do it in my experience. So we go from 4A, we jump to 4D. You'll notice we don't bother with 4B. Okay? B is just introducing you to the idea of backwards integration, but we're doing that in our notes book. I think we do a better job than the textbook does. Nonetheless, we're going to start with 4A, and we have consider the equation y equals 2x plus 1, and we're asked graph the function over the interval from 0 to 2. Okay, so here's our x-axis, here's our y-axis. This is the equation of a line. We're going from x equals 1 to x equals 2. This line has a y-intercept of 1, so that's where we'll start. And it has a slope of 2, so that means we're going to go across 1, up 2. Across 1, up 2. And this is what the line would look like. Now we're asked to graph it from 0 to 2, so we're graphing it over this region, right? Here the y value is 1, here the y value is 3, because it's gone up 2 spaces. And here the y value is 5. Okay, really good. Sketch the function. Now what we're going to do is, one thing we will be doing in integration is finding area under a curve. So that means like how much square units exist under the curve. Now one method we will use is what's called lower rectangles, and one we will use is called upper rectangles. And that's going to be an estimate for the area. So one way we could estimate this area is if we want to know the area that exists under the curve, right? Is I could do 2 lower rectangles under the curve, and if I find the area of these rectangles, they are going to be an indication of what the area is, albeit they will be less than the actual area. Okay, so if I find the area of these 2 rectangles, it's going to be an approximation for the area under the curve. Okay, so this is going to be our lower estimate. And all we're going to do is go, well, it's going to be the area of rectangle 1, which is 1 times 1, plus the area of rectangle 2. Now rectangle 2 has a width of 1 and a height of 3, so plus 1 times 3. And so that's 1 plus 3, that gives us 4. Okay, so that's a lower estimate, and it's lower because it's an underestimate, right? We have an upper estimate, which is where we'll draw the same function again, but this time we'll draw upper rectangles. Now, upper rectangles are drawn like this. Okay, and if I find the area of these rectangles, we can see that this estimate is going to be an overestimate because I've over-calculated the area. So for our upper estimate, we would have, 1, 2, this is 3, and this is 5, and this is 1. So for our upper estimate, the area is going to be 1 times 3 plus 1 times 5 okay, which gives us 8. Now what this means is the actual area lies somewhere between 4 and 8. Alright, what do we think would happen if we increased the number of rectangles? Okay, yeah, it's going to become more accurate, isn't it? Certainly. So let's have a look. Let's just compare the lower estimates for now. So I'm going to highlight to you the amount of error. Okay, here we have this much error plus this much error. If we are to use 4 rectangles, I'll draw lower rectangles, and we'll draw 4 of them. If we were to use 4, this is falling apart. If we use 4 rectangles, we would have 1, 2, 3, 4. Okay, what we can see is if we use more rectangles, there's going to be less error. We've gotten rid of the error that exists there. Alright, so the more rectangles we use, the closer our estimate will be. Okay, so let's write that for part C or D. What will happen if you increase, we've gone from A, B, D, of course we have. What will happen? It will increase the accuracy. Okay, check by doing 4 upper and 4 lower rectangles. Okay, so if we're dividing the interval from 0 to 2 into 4 rectangles, well, each rectangle is going to have a width of 0.5, right? So this was using 2 rectangles, and now let's do it using 4 rectangles. Okay, so for our lower estimate, it's going to be 0.5 times 1 plus 0.5 times 2 plus 0.5 times 3 plus 0.5 times 4. Alright, now I think if we're writing this out, one thing we should notice is 0.5 is common to all of them, right? So we can pull 0.5 out the front. It's 0.5 times, and we have 1 plus 2 plus 3 plus 4. Alright, so it's just half of 1 plus 2 plus 3 plus 4. So what's that? 3, 6, 10, half of 10 is 5. Okay, so using the lower estimate now, we have a lower estimate of 5. And for our upper estimate, a way to think about the upper estimate, I might sketch it underneath it, you might see it clearly. .51 and 0.52, 1, 3, 5. Okay, what I want to point out about the upper estimate compared to the lower estimate is they're almost the same. There's something very slightly different to them. If you look at these 3 rectangles and move them across one space, that rectangle goes there, that rectangle goes here. All we're doing with the upper estimate is moving these rectangles across one space. Okay, so that means we've got this part of the calculation plus another rectangle there, right? Okay, so for our upper estimate, it's going to be 0.5 multiplied by 2 plus 3 plus 4 plus, okay, so the height of the second, the height here, 2, 3, 4 plus 5. Okay, so that takes us to what? 5, 9, 14. Half of 14 is 7. So now we can see, using more rectangles, the region over which our area is. The constraint is between 5 and 7. So we saw, using more rectangles, we have increased the accuracy. Before, it was from 4 to 8, using lower estimates. Now it's from 5 to 7. So the point here is just to draw out something fairly obvious, I think. Using more rectangles will improve accuracy. Very good. On to part F, we have find the solution, find the exact area using a geometric answer. Okay, so here we have the graph, and I want to know what's the exact area under this curve. Okay, using a geometric argument means using knowledge of rectangles and triangles and how we find area. So what we'll do is we'll just divide this into a rectangle and a triangle. All right, the area of the rectangle is 1 times 2. And the area of the triangle is always half the base times the height. And in this case, the base is 2. And the height of the triangle goes from y is 1 to y is 5. The height is 4. Okay, so we'll have 2 plus half of 8, 2 plus 4, we'll have 6. Now this is interesting because 6 lies exactly halfway between our lower and our upper estimate. Now this will be the case for a straight line, however it won't be the place for a curve, which we will do mostly. Okay.
Is it units squared?
Yes, for area we should have units squared. Good pickup. Alright, so let's go to number 2 then. Find the integral from 0 to 2 of x squared. And we'll talk about what this is going to mean for us. Okay, so the question says, now for now, all this is going to mean for us is find the area under the function x squared from 0 to 2. Okay, the area under the function x squared from 0 to 2, and we're told using 2 upper and 2 lower rectangles. So if we sketch the curve of x squared from 0 to 2, this is what it looks like. And if we want to divide that up into 2 rectangles, okay, so we have from x is 1 to x is 2. And if we're doing upper rectangles, we'll do those first. Here's my first upper rectangle. Here's my second upper rectangle. So my question is, what's the y value here?
1.
1, good. Remember, y equals x squared. So the y value of that point is 1 squared. The y value of this point is 2 squared, which is 4. Good. So for our upper estimate, we can call it u for upper. We will have 1 times 1 plus 1 times 4. So that's what 5. Okay. Then for our lower estimate, I'm going to draw our lower estimate on the same one, so just to save a bit of space and so forth. For our lower estimate, alright, the first rectangle is going to be this one, and then the second rectangle, we start at the point lowest on this curve, which is here. So that means this rectangle here actually has a height of 0. Alright, so our lower estimate really only consists of 1 rectangle. So you can think of it, this first rectangle has a 1 times 0, and the second rectangle is 1 times 1, which means our lower estimate is 1. So the area lies somewhere between 1 and 5. What do we think it's going to be closer to? 5. It's going to be closer to 5 or closer to 1. That's going to be a question that I think we'll answer a bit later because it involves concavity and the margin of error and so forth. Let's not explore it just yet. Okay, so that's our notes here, isn't it? So what we'll do, we'll start with exercise 4A.1, and if you look at our checklist at the front, okay, 4A.1, we have question 1 and 2, but But then we're going to use some software for question 3 and 4. So for our first test, just on the rules of integration, will be in chapter 4. And then we have applications of integration, which is in chapter 5. Okay, so for 8.1, we'll have question 1. 2, I might provide a few prompts for. But then 3, 4, 5, we can use our online software for. Someone's drawn in your book.